This is the Phenom Academy of Life Sciences. Today we are presenting a topic, Hess law of constant heat summation. It's a topic in Form 4 under the chapter Energy Changes in Physical and Chemical Processes. Now, before we look at this topic, I would like to direct you to our channel in YouTube, the Phenom Academy of Life Sciences. We have several content in biology practicals actually. We have done male reproductive organ, whereby we have dissected a rabbit and exposed the male reproductive organ. We have done the transverse section of a penis, and also we have talked about vasectomy. We have also another practical inside the mammalian uterus, whereby we have exposed the placenta, the allantois, the amniotic fluid, and all other organs inside the mammalian uterus. We have also done dissection of a rabbit, the digestive system, and associated glands. And therefore, it will be good for you if you check out this biology content. Now, let's now turn on to the Hess law of constant heat summation. And actually, by the end of this lesson, you, the learner, must be able to state Hess law, carry out related calculations, draw an energy level and an energy cycle diagram, and be able to define molar heat of formation. So what is molar heat of formation? Now, if you have magnesium, you can burn magnesium in the lab. Magnesium will burn in the lab in the presence of oxygen to produce magnesium oxide. And using a calorimeter, we have a calorimeter here. Come closer. This is a calorimeter. This is a calorimeter. A calorimeter is an instrument used to determine specific heat capacity of substances and molar heat of formation of several substances in the lab. It has several areas. This is where you connect the voltmeter. Now this is the thermometer. This is the stirrer. Sorry. This is the stirrer. And this is actually lagging so that no heat will be lost. So this is a calorimeter which will determine heat of formation of several substances in the lab. This is what we have said. 1 mole of magnesium will burn in half a mole of oxygen to produce magnesium oxide. So it is possible in the lab to determine the molar heat of formation of magnesium oxide. Molar heat of formation is the heat change which occurs when 1 mole of a substance is formed from its constituent elements in their standard states. So for you to form 1 mole of magnesium, you will need, for you to form 1 mole of magnesium oxide, you will need 1 mole of magnesium burning in half a mole of oxygen to produce that. So in the laboratory, you can use a calorimeter to determine the molar heat of formation. You can also determine the molar heat of formation of carbon 4 oxide. If you burn carbon in oxygen, you will get carbon 4 oxide gas. 1 mole. For you to form 1 mole of carbon 4 oxide, you will burn 1 mole of carbon in 1 mole of oxygen to form this. Substances whose reactions can practically occur in the laboratory, their molar heat of formation can be determined experimentally using a calorimeter. However, several other chemicals, for example, like methane gas, the constituent elements in formation of methane are carbon and hydrogen gas to form methane. However, this reaction cannot practically occur in the lab Carbon cannot react with hydrogen under ordinary conditions in the laboratory. And therefore, such compounds, you determine the molar heat of their formation indirectly. Indirectly. You determine the molar heat of formation indirectly using the Hess law of constant heat summation. Under these circumstances, you will connect several other measurable enthalpies. For example, the molar enthalpy of combustion of methane, you determine that. You also determine the molar enthalpy of formation of carbon. The molar enthalpy of combustion of carbon, and also the molar enthalpy of combustion of hydrogen. And then these enthalpies are connected in an energy cycle diagram. Now, we are given this data. We have given this data. This data tells us 1 mole of carbon burns in 1 mole of oxygen to produce carbon 4 oxide. And the heat liberated is minus 393 kilojoules per mole. 1 mole of hydrogen burns in half a mole of oxygen to produce 1 mole of water. The energy produced is negative 286 kilojoules per mole. 1 mole of methane burns in 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water, and the energy liberated is 890. So using Hess law of constant heat summation, you will connect the molar heat of combustion of methane, the enthalpy of that, the enthalpy of combustion of hydrogen, and the enthalpy of combustion of carbon in an energy cycle diagram, which all these will now be connected with the heat of formation. This is what you have seen. Heat of formation of a substance is the energy change which occurs when 1 mole of a compound is formed from its constituent substances. So this is what we do. You write now the equation of reaction of the constituent elements producing that compound. So we want to calculate the molar enthalpy of formation of of methane. So you write first the constituent elements in their standard states. Now, we are saying you connect an energy cycle diagrams using measurable enthalpies. So when this methane burns in oxygen, these are the products. So you write the products somewhere here below this reaction. So you have CO2 gas plus 2 moles of water. So when you burn methane in oxygen, you will get these products. So this is heat of combustion. Heat of combustion of methane, which we are given here, minus 890. You write minus 890. Now, when carbon burns in oxygen, you form carbon dioxide. When hydrogen burns in oxygen, you get water. So you connect this. And you also connect that. This is oxygen. This is burning in oxygen. And this is burning in oxygen. This is heat of combustion of carbon. Heat of combustion of carbon is minus 393. minus 393. Now we also need to calculate the molar heat of combustion of hydrogen. However, in formation of 1 mole of methane, there are 2 moles of hydrogen. This equation shows us the heat of combustion of 1 mole, which is minus 286. So, these are 2 moles. So it will be minus 286 times 2. Now look, for you to get these products, there are 2 routes you can use. There is this route. You can follow that route, whereby first you form the methane. Finally, the methane burns in oxygen to produce this. You can also burn these constituent elements directly to get these products. This is another route. So we have route 1 and we have route 2. This is now the essence of Hess law of constant heat summation. This is what it states. In converting reactants to products, the energy change which occurs is the same regardless of the route followed during the chemical process. And therefore, this is what we are saying. Route 1 is equivalent to route 2. So we can say route 1 is equals route 2. Route 1 can be seen as A. We can call that A. We can call that B. We can call this C. We can call this D. And therefore, this is what we are saying. A plus B is equals C plus D. C plus D. Now, we know the enthalpy of combustion of B. We know C and we know B. We now need A to calculate the heat of formation of methane. And therefore, A is equals C plus D minus B is equals C. This is C. Yeah. 286 times 2 is 572. So this is minus 572 plus D minus 393 minus B minus 890. Now this gives you minus 965 plus 890 minus 75. So the heat of formation of methane is minus 75. What does minus mean? It is an exothermic reaction. So you say minus 75 kilojoules per mole. During the formation of methane, this energy is liberated. And therefore, this is the energy cycle diagram. We can also show an energy level diagram. And in this case, you'll have a vertical axis and horizontal axis. This shows reaction progress, and this shows energy. That shows energy in kilojoules. Energy in kilojoules. Now, because we have seen this is an exothermic reaction, definitely the reactant will be at a higher energy level. And so, whenever you are drawing an energy level diagram, always have an energy level diagram above here representing the reactant. Now, because this A is negative, it shows energy was given out, and therefore these products are at a lower energy level. Therefore, you show it somewhere there, CH4 gas. And then you also have another energy level there at the bottom. Actually, in determination of heat of formation during Hess law, when you are making an energy level diagram, you only need 3 energy levels. One for the reactants, another for the formed product, and then the products. So these are the products. CO2 gas plus water in liquid state. Therefore, you connect all that. This is the summation of the heat of combustion of carbon and hydrogen, and it is minus 965 kilojoules. Now this is minus 890 kilojoules per mole. Now, Hess law of constant heat summation states this. In converting reactants to products, the energy change which occurs is the same regardless of the route taken during the chemical process. So we can say A, we say that is B, and that is C. We can say A is equals B plus C. A is equals B plus C. And therefore, B is equals A minus C. A is minus 965 minus C minus 890 is equals minus 75 kilojoules per mole. You write it here, minus 75 kilojoules per mole. That is how you determine the Hess law for compounds whose elements cannot react in the laboratory. Now, this is the conclusion of our lesson. If you have to determine Hess law, you will need to know the elements which react to produce your compound. You will need to know how to calculate the heat of combustion of the compound and the constituent elements, and how to link them in either an energy cycle diagram or an energy level diagram. Now, this is the assignment I want to give you. Given this information, this is the information given. So, given this information, calculate the molar enthalpy of formation of a thion from its constituent elements. That marks the end of our lesson. Thank you, and please go to the Phenom Academy in YouTube and get more content on practical lessons in biology and chemistry. Thank you very much.